Hello students, good morning students. Yesterday we left a few questions dipole moment based. I already explained you yesterday this question 2024. Here once again look at the 2024 previous year's questions dipole moment based. Here this question is number of compounds from the following with non-zero dipole moment. Non-zero dipole moment. Non-zero dipole moment means dipole moment not equal to zero, that is polar molecule. So polar molecule. So the question is among the following which are polar molecules, students. So observe that BeCl2. What is the shape of the BeCl2? Beryllium group number is 2. Valence electrons 2. So chlorine overlap with that electron, chlorine overlap with that electron. Here the beryllium dichloride, the shape is linear. This is this direction, this is this direction, net dipole moment value 0. It is non-polar molecule. Non-polar molecule. The shapes of the molecules already I gave you yesterday's classes. BeCl3. What is the central atom here? Boron. Group number 3. Valence electrons 3. Around the boron 3 chlorines are present. They are overlapping like this. The chlorine valence electron. Now here what is the shape of the molecule? Total pairs 3. Bond pairs 3. Lone pair 0. What is the shape of the molecule? Trigonal planar. Trigonal planar. The trigonal planar case dipole moment, what I said? Dipole moment 0. It is non-polar. Non-polar molecule. Next NF3. NF3 central atom is nitrogen. Group number 5. Valence electrons 5. What is the shape of the NF3? Pyramidal, like ammonia. So pyramidal dipole moment not equal to 0. It is the polar molecule. Polar molecule. So based on this point, observe here which of the following given molecules are non-zero dipole moment, polar molecule. NF3 is the polar molecule because of pyramidal arrangement. Next is XeF4 is the square planar molecule. CCl4 is the tetrahedral. Dipole moment is 0. Here the dipole moment is 0. Water is the polar molecule. Dipole moment not equal to 0. BeCl2 dipole moment equal to 0. BeCl3 dipole moment equal to 0. H2S dipole moment not equal to 0 because of bent shape like water. Next HBr, bromine is the more electronegative element. The bonding electrons moving bromine side. Dipole moment not equal to 0 is the polar molecule. CO2 is the linear shape, dipole moment 0. H2 homodiatomic molecule, dipole moment 0. HCl dipole moment not equal to 0. So among the given molecules which are having non-zero dipole moment, 1, next 2, 3, 4, 5. How many molecules here? Overall 5 molecules are there. So this is the 2024 mains question, students. Dipole moment calculation is the polar molecule or non-polar molecule. We are understanding based on the shape of the molecules. Shapes of the molecules I already gave you explanation in last previous videos. So once look at that. Next question. Look at the next question, students. JEE mains question. This one also JEE mains question. So which of the following molecule has maximum dipole moment? The word used. Which is the maximum dipole moment? CH4, the second molecule, dipole moment is 0. Already we know that because of all the surrounding atoms are same. Tetrahedral arrangement. PF5 like a PCl5. PF5 it is look like PCl5 structure. PCl5 dipole moment equal to 0. So PF5 dipole moment also 0. Next, ammonia. What is the shape of the ammonia? Pyramidal arrangement. Next, what is the shape of the NF3? This is also pyramidal arrangement. Pyramidal arrangement. But observed here the nitrogen having the lone pair of electron. Here also nitrogen having the lone pair of electrons. In this, in the ammonia, the whole molecule, the bonding electrons, sigma bonding electrons, the electron density moving only one direction, nitrogen direction, the whole electron density in the one direction only. There is no any cancellation in this case. But in this case, nitrogen and fluorine comparison, fluorine is the more electronegative element in the periodic table. The sigma bonding electron density moving fluorine side. And lone pair also having the dipole moment, it is moving this direction. Like something cancellation is existing in the NF3 case. So NF3 and NH3 both are pyramidal arrangement. The shape is pyramidal, but the dipole moment mu NH3 is more compared to NF3. Reason, here in the NF3 molecule there is a cancellation is existing between lone pair dipole moment and fluorine dipole moment. Both are oppositely existing. So dipole moment here NF3 is less compared to NH3. So maximum dipole moment which molecule is having maximum dipole moment, that is NH3. Methane dipole moment 0. Here the dipole moment is 0. Next question. This is also 2024 question. Choose polar molecule. Polar molecule. Among the following, which is the polar molecule? The CCl4 like CH4 arrangement, the tetrahedral arrangement. Molecule is tetrahedral arrangement. Surrounding atoms are same. Dipole moment 0. Dipole moment is 0. Carbon dioxide, already we know that C double bond O, C double bond O, linear shape. Dipole moment here also 0. So dipole moment is 0, non-polar molecule. This is non-polar molecule. Next C2H2, CH2 double bond CH2, CHCl3. Here this molecule observed here, alkene, ethene. All the surrounding atoms are same. Hydrogen, 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 hydrogen. Here the carbon, carbon. There is no any polarity, but here this is this direction. This is this direction. Carbon is the more electronegative element. Here the cancellation to each other. This is this direction. This is this direction. Cancellation to each other. So dipole moment value 0. Oppositely moving the electrons. Carbon is the more electronegative element compared to hydrogen. Next molecule is CHCl3, chloroform. Chloroform structure is a tetrahedral arrangement. Chlorine, chlorine, the chlorine. Here, this is this direction, this is this direction, this bonding electron this direction, this is this direction. So, among the remaining cases, this is non-polar, this is non-polar, this is also non-polar. Non-polar. But in the fourth case, in the case of chloroform, dipole moment cancellation is not possible. Dipole moment something is existing because of all the surrounding atoms are not same. So it is the polar molecule. Chloroform is polar molecule. Dipole moment not equal to 0. So option CHCl3. This is 2024 question. Next observe here. The number of non-polar molecules. The question, number of non-polar molecules, that means dipole moment equal to 0. So here H2 dipole moment 0, CO2 dipole moment 0, methane dipole moment 0, next boron trifluoride dipole moment 0. So how many are there? 4. So H2, CO2, CH4 and BF3. Dipole moment 0, non-polar molecules. Non-polar molecules. But the remaining cases, if you are observing HF, H2O and SO2 shape is angular shape. Ammonia shape is pyramidal. HCl, chlorine is more electronegative element. Chloroform, just we discussed. So these are dipole moment, these molecules not equal to 0. These are all polar molecules. So how many molecules are there in this question? 4 molecules are there, non-polar molecules. Next question, students, here. Among the following, one which having highest dipole moment. Highest dipole moment means dipole moment not equal to 0. Which one? These are the questions given based on the polarity of the bond. Polarity, double bond is present, here the double bond, here the double bond, here the double bond. Once look at the first molecule, double bond, here the molecule is existing like this. I'm shifting this pi bond towards this direction, After shifting towards this carbon atom, the resulting structure, the 5-membered ring, this carbon gets negative charge, this carbon gets positive charge. So now here observe, in this area overall how many electrons are present. Aromaticity concept I explained previously. Aromaticity based. This question is based on aromaticity. 1, 2, 3, 4, 5, 6. Negative charge also considered as 1 pi bond. 6 pi electrons are there. Here 2 pi electrons are there. It follows Huckel's rule. The molecule follows the Huckel's rule. Here Huckel's rule. 6 pi electrons, 2 pi electrons. This is aromatic. So after bond rotation from here to here, what is the compound? Aromatic compound. Aromatic compounds are highly stable, so it is more polar in nature, more polar bond. So remaining cases, so more polar means more dipole moment is existing, more dipole moment. Remaining cases, aromaticity is not generating after bond rotation. After bond shifting, this is not aromatic compound. After bond rotation, one is aromatic, another one is anti-aromatic. After bond shifting, both are non-aromatic because of here sp3 hybridizer carbon. sp3 hybridizer carbon is present, non-aromatic. Non-aromatic compounds are unstable. So after bond rotation, this direction, the resulting compound is aromatic. So that's why this nature of the bond is more polar in nature. Highest dipole moment. These are the 2024 dipole moment based questions, students. So give the importance in the chemical bonding lesson dipole moment area, because of dipole moment based many questions are asked in different pattern examination, not only mains examination. Okay students, bye students.